In the previous lectures, we have talked about selection sort and bubble sort, two of the easier sort methods that we can learn about. So now we're going to up the difficulty a little bit and begin talking about merge sort. And merge sort is an algorithm that is considered to be an example of dividing and conquering. So this algorithm, what we're going to do is initially divide the array into two equal halves, and then they are combined in a sorted manner, right? So we're going to divide and conquer and then remerge them back together into a sorted final array. So let's take a look at what that means. So a very high level view, we'll say that we have an array of 4, 7, 3, 5, 1, and 2. So this is our initial array right here. So we have all of our elements, and we know that this is going to be a divide and conquer. So we will say we're going to divide right here at the midpoint. So divide the array in half. So now we have two arrays, 4, 7, 3, and 5, 1, 2. So again, this is very high level, and then we will go over a little bit more in depth after we get this high level view out the way. So now we have divided our initial array, and now we want to conquer in a way, aka sort it, and then we want to merge it back together. So now we're going to sort it, so 3, 4, 7, and then 1, 2, 5. Again, these are their own arrays. And now that we know that these have been sorted, we want to merge it back together. So 1, 2, 3, 4, 5, 7. So now we have merged them back together, and we just executed merge sort. So how can we eloquently kind of evaluate how this works? Well, we're going to have a couple of things that we need to do. So with this being, if you might have kind of saw it, this is actually going to be a recursive algorithm, because we're going to continuously divide and conquer. So we will continuously call on one of our functions in order to continuously break down our array until we have a very basic one, maybe two element array that we can very quickly sort, and then start unwinding the stack and merging everything back together. So we're going to have a base case where the array length is equal to 0 or 1. And then the steps that we want to do is we want to break the array in half, call merge sort on both halves, and then lastly, the most important part, we want to merge the two sorted arrays. Okay, so now let's look back at our initial example, and because we want to see how this works, obviously throughout the entire process. So let's give ourselves some additional space down here, and let's leave our base case and everything. That way we can kind of see what we're working with. So our array was what did we have? 4, 7, 3, 5, 1, 2. So we want to sort 4, 7, 3, 5, 1, 2. So I went ahead and kind of split it up because we already know that that's what we're going to need to do. So we have our two arrays right here. Well, what we're going to want to do here is split this array up. So our midpoint is going to be this 7. So what we'll do is we'll create an array with 4 and 7, and then we'll have 3 here. Well, obviously 3 is sorted because that is its own array with one element, so that satisfies our base case. But 4 and 7, we can split it up even more. We can split it up into 4 and 7. So now we know that 4 and 7 are sorted and our base case is satisfied, so we can also begin working on this one. So we will have 5 and 1 and then 2. Obviously 2 was sorted, and now we will have an array of 5 and 1 here as well. So we now have a total of 6 arrays, technically, of 4, 7, 3, 5, 1, and 2. And now that we have call merge sort on everything, we want to begin merging all of our sorted arrays. So down here we know that 4 and 7, so up as we unwind, our sorted array here is going to be 4 and 7. And now we're at the level where we have the 3, so we're going to merge the 3 back in. So now we know that we're going to have 3, 4, and 7, and that's going to be our final array there. Over here we're going to have 1 and 5, and now we need to sort in the 2. So up here we're going to go 1, 2, 5. So now we have our last 2 arrays that need to be sorted, and they will obviously sort to 1, 2, 3, 4, 5, and 7. So as you can see, the complexity of this algorithm is a little bit more difficult than our previous 2 in bubble sort and selection sort. But hopefully you have a good understanding of how this is going to work, and now we will begin implementing this algorithm in the next lecture.